This presentation takes a critical look at the CORSIA agreements in international aviation that promise to stabilize emissions between two countries that are signatories. Emissions of bilateral flights can be stabilized via offsets or via sustainable aviation fuels. But signatories do not necessarily agree on the quality of the offsets and sustainable aviation fuels. Stef Proost, economist at the University of KU Leuven in Belgium, explains why CORSIA will probably lead to limited participation and limited climate effectiveness.
This is joint work with two of my former students, Saskia van der Loo and Inge Meijers. Okay. It's actually maybe somebody from DLR is in the room. It's actually part. Okay. Hi. We are part of a consortium looking at assessing what is the best way to decarbonize aviation in different ways. So this will be one of the models we could use for that. It's a little bit strange, but okay. Let me start by saying what is CORSIA. Maybe those of you who are not in aviation, CORSIA is an agreement reached within the International Civil Aviation Authority, some kind of United Nations body. And what is important, it caps emissions for international flights between two countries that signed the agreement. That's what we will try to explain. And then you are allowed to cap these emissions by the use of offsets. What are offsets? It's additional abatement in other sectors or by using sustainable aviation. Now, many countries signed, but what does it mean? Does it mean that we will see an effect, yes or no? Okay. Is it important? Yes. Let's say if you look at percentage of the world emissions in aviation within the EU, here within the rest of the world, for us, everything is the rest of the world here, okay? Except for everything which is EU to rest of the world and rest of the world country to rest of the world country. So these yellow parts, they are covered by CORSIA. So it's a very important part of total emissions. Now, the second point to remember is that this is in principle covered by the Paris Agreement. Also, the US and China, they're also covered by the Paris Agreement. Everything which is inside the country is covered by the Paris Agreement, but this is covered by the CORSIA Agreement. So what CORSIA hopes to, okay, this is the ambition of CORSIA, is that, of course, overall emissions of aviation went down in the last 2-3 years. But now they say, okay, we will try to stabilize at a given level, 2019, using different types of approaches, aircraft technology, operational improvements, SAF, whatever, so other types of fuels. That's the ambition. Now, I would like to discuss 3 issues together with you. One, and it's very often forgotten, is that international agreements are inherently weak. They are weak. And that's, I think, a very important point. So it will be, you have to study effective participation. Effective is not signing, it's really doing something. And it's very different. The second point is whenever you start to deal with offsets, you need credible offsets. A third point is very important. Carbon neutral is not climate neutral. Whenever you deal with aviation, it can be something very, very different. So what I will try to do is set up a very small model of participation decisions. I try to illustrate it numerically, okay? Not for 190 countries, whatever, but for 10 countries, which we think is very important, and try to discuss improvements to CORSIA. The first point, and let me repeat, this is an important point. An international agreement cannot be enforced. Nobody can tell you, you signed the agreement, you have to do it. No, because there is no sanction. There's no sanction mechanism. Imagine that the US doesn't comply with Paris. Can Belgium send a fighter jet to the US? So there is, and we say we gotta try to punish them with trade sanctions. Whenever a country starts to use trade sanctions, it also hurts itself. Okay, so it's very difficult to enforce. Even explicitly in CORSIA agreement, no country can punish a country that withdraws from the agreement. So it's very explicit. So the result will be very often close to Nash, in the sense that you try to take into account where it benefits you, where it tries to avoid your type of damage. You will not take into account this world social marginal cost of climate, maybe 100 or 200 or 300. Okay, that will not be driving the behavior of the countries. Now, I know national politicians negotiate agreements. There's a way to explain why politicians negotiate agreements, but anyway, if the sanctions are weak, what you will see is that sometimes countries will try to comply with a green politician, and then you get a brown politician say, no, let's calm down. Okay, so this is a very important point. I'm not going to explain that. The second difficulty with offsets is that it's a compensation of aviation emissions by additional reductions in other sectors. It has to be additional efforts. And it's additional efforts on top of the Paris Agreement. Now the problem of who is going to certify that, who is going to control that. And there's actually kind of asymmetric information problem. I know there exists an international market of certified offsets, but when you look at the prices, they range from €1 to something else, while in Europe, the prices of ETS, which is a kind of certified followed up, is 50 to 100. So it's clear that countries that will participate will require quality guarantees, and they will probably say, okay, whenever I can buy something for €10 or for €1, it's not taken seriously. Okay. Third important point, whenever you discuss aviation, international aviation, is that carbon neutral growth is not the same thing as climate neutral. The reason is very simple, is that whenever you have emissions high in the air, you produce extra climate emissions, you produce extra climate effects, and they are well documented in atmospheric science. It's too difficult for me, but they exist. And okay, there is a peer-reviewed literature on that. And I think my take of that is that this represents, whenever if you take 1 ton of carbon emitted in a car or in a truck, and you compare it with 1 ton of carbon emitted high in the air, it counts for 3 times more. An immediate consequence is that you say, I'm going to compensate it with offsets. It cannot be correct. It cannot be correct. Even high quality offsetting is thus insufficient to compensate the growth in climate effect of aviation. Okay, very simple idea. Okay, we're going to build a very simple model. The model will be extremely simple, okay, based on 4 assumptions. First assumption, country, representative citizen in a country, it's quasi-linear utility function that is separable in a different international destinations. So no substitution in one country A to B, A to C are no substitutes. It's not correct for tourism, but it's maybe makes sense for many other, let's say, types of motives. The second assumption, many people will object, the marginal production cost of applied is constant, and there is perfect competition, of course. Many people will say, yeah, doesn't make sense, okay, just to start going. The third assumption is that the stock of aircraft is homogeneous, okay, and its fuel efficiency is fixed. And have a look at the papers presented here by Jan and Fagina and Exido, also at this conference. They explain you how important it is to select the right aircraft, the speed of the aircraft, all these things. Final assumption, the marginal climate damage per country of a ton of carbon emitted on land is constant. You have a small sector, so I think could still make sense. These assumptions guarantee that we can study the participation question in a separable way. We can study whether A and B participate, and whether C will participate. C and D does not affect A and B. Makes things much simpler. Okay, this is my model. As usual, extremely simple. What I do is, first of all, I switch to the energy dimension rather than the flight dimension. The energy dimension, I have here the price of aviation fuel. Here's the price level of kerosene. I keep it fixed, okay? Here I measure the quantity of fuel for intercontinental flight two ways. Going there and coming back will be important in what is coming, because I'm discussing connections between different countries. Okay. So what I have is, I'm also going to assume that country B also participates. Okay. And more or less that there's an agreement on the price of offsets. This will be the price of offsets. I'm discussing here energy. So it's the same dimension. Kerosene, it means that whenever I need an offset, I will increase the price of energy used for aviation. Okay. I have a demand for aviation, which here is translated into energy demand. Okay, demand in 2019. I have a growth in volume, okay, of aviation. I expect by 2035, 2040 to have much more flight, much more activity. It can be maybe a little bit more efficient, but this will be the corresponding demand for aviation fuel in 2030. So I have here some kind of growth. Okay, what does CORSIA really promise? It promises that here the total emission or the total use of carbon in 2035, whatever it should be here, okay, that this is reduced back to this level. I kept carbon emissions to the level of 2019. And this promise, okay, I will achieve it by using here in this case offsets. Offsets here, first effect to see is that, of course, price of using energy gets higher. I will have less flights, more efficient flights, whatever. So here, this will be the first movement. I will reduce energy used by this part, and I will compensate this growth in energy by using offsets. So I will buy these amount of offsets to make sure that I stabilize emissions. Okay. The next step is try to make a model. What is the benefit of participating in this agreement? And here, what we see is we take into account what I explained before. First of all, the fact that I reduce energy use in aviation. Here, I have less aviation, less flights, less energy use, has a very big benefit. The benefit is 3 times larger than just the cost here, than the price of offsets. Because I count everything which is reduction of energy, I count it 3 times more. Because of my climate effect is much larger than my carbon effect. Okay, but I still have my offsets, and offsets also take part, also compensate or have some net benefits. What is the difference? I have to take into account that there will be grandfather permits. Okay, there will be this part, compensation, producer surplus, consumer surplus. In addition, this is flying there and coming back. So I only have to count, you can see it in different ways, only have to count half of the loss of consumer surplus and producer surplus, because interconnection between 2 countries is like a trade deal where you separate, you just divide the benefits. You can also say that half of the people are from another country, the other half are from my country. So there are different ways to explain this, but you have to make sure that you only use half of the loss of consumer surplus and producer surplus. Okay, let's move to the numerical application. I take 5 minutes, perfect. 10 important countries. I use expected growth rate, international aviation, price of kerosene, minus 0.43, whatever. And then I use a national willingness to pay to avoid climate damage. And of course, yeah, you will ask a politician, yes, we will always say it's very, very important. And maybe I will cite €200, but I try to use OECD data on what I call some kind of effective carbon pricing, and I call that revealed carbon pricing. That's the best source I could find about what is the willingness to pay, national willingness to pay for of different countries for aviation. And I find some data, willingness to pay to avoid carbon damage counted at the level of land, okay, surface. Is 28, 13 for the US, here 13, Japan, whatever, much lower for China. Then I use the model. How do I use the model? I start by fixing one offset price, let's say €28 per ton. It's about the price willingness to pay for avoid damage by the EU, okay? And I take one country here. For each country, I count different types of bilateral movements, bilateral flights. Australia, you go to Canada, and I compute here, in this case, 0.97 is the net benefit of Australia joining CORSIA if Canada also joins, because you need a bilateral agreement, okay? And you will see that here, China is also benefiting for Australia, given their willingness to pay to avoid climate. China would also be interested, but China has a much lower willingness to pay, national willingness to pay for climate damage. Here is China, and China will not join CORSIA. So I have to check for different countries whether there is a bilateral possibility of agreeing. And I will figure out that Australia, Canada, EU, Japan, US will sign the agreement according to this type of computation. Important to see is that it's not simply €28 that really counts. It counts also whether the expected growth rate will count. You also have to take into account that whatever you actually, what you're actually doing is for a bilateral agreement, it's an opportunity to address emissions in both directions, okay? And given that consumer surplus and producer surplus only counts for half, so that's a very important driver for participation, okay? So growth rate will be important. Low offset price that everybody will join, but that's not serious, okay? Next point is, I have a graph that is missing, okay? Yeah, that is important. Let me briefly explain. With these data, you can also try to see where it makes sense for duopoly. Duopoly in this case is Boeing and Airbus, where it makes sense to make an extra investment subsidized by the US and the EU. And we try to compute what would be the extra benefit, also in terms of participation and also in terms of reduction of emissions. So we made a small experiment. Imagine that flights become 25% more efficient, but on net terms, they do not cost less. They keep the same price, so we have no rebound effect. And then you can show the benefit would be of the order of 1.6 billion. And this 1.6 billion for the EU plus the US, you can compare it with the R&D budget of Boeing, which is 2.5 billion, something like that. So things are that order of magnitude. And that brings me to my conclusions. Okay. Still work to be done. Introduce blending mandate for SAFs. We are busy with that. I do not count too much on SAF. Add effects on connecting flights. There may also be cooperation beyond CORSIA. You can show that even if you cannot make binding contracts, it may be in your interest to sit together and do something extra, even if nobody can afford the contract. So that's something we still are working on. Add a supply model for aircrafts, which is, I think, a very important point for many people in the room, and add a supply model for airlines. That's it. Thank you very much.